Welcome back to another physics lesson. I'm still your physics teacher, Mr. Moses. Welcome back. This time we'll be looking at gas laws. And when we say gas laws, we are looking at the laws that govern the existence of gases. First, we'll be looking at the presence of a gas. We are surrounded with gases everywhere we look. The way we can know that we are surrounded with gases is by their smell, if they have an odor, how we feel them when they move. We feel gases when they move. And if they have color, we can see them. But gas molecules are everywhere around us. And then we move to the temperature of a gas. We said this is the average translational kinetic energy of the molecules of the gas. That means that gases are in constant motion, and then when temperature is added to a gas, the molecules of the gas gain kinetic energy. When they gain kinetic energy, they move very fast and cover large distances. When there is an increase in the temperature of a gas, the molecules of the gas vibrate more. Their kinetic movement increases, and hence they cover larger spaces. So the volume also increases. But when there is a reduction in temperature, the kinetic energy reduces and the volume reduces, just like you have in the diagram above. An increase in temperature raises the kinetic energy and the volume of the gas, but a decrease in temperature reduces the kinetic energy and the volume of the gas. So when we talk of temperature of a gas, we also talk about the kinetic energy of the molecules of the gas. As you can see above. And then next we'll go to gas pressure. We said here that gas pressure is the force per unit area of a gas. When gases are heated, they gain energy and collide more with the walls of their container. This collision per unit area is termed gas pressure. When we hear the word gas pressure, we're talking about the collision of the molecules of the gas with the walls of the container. If you put a gas in a container, the molecules that are at random motion collide with the walls of that container. That collision is what we term gas pressure. Like the example above, when you blow a balloon with air particles inside the balloon are moving at random motion and hitting the walls of the balloon. It is the collision of the air molecules and the walls of the balloon that actually increases the size of the balloon. Yes, so gas pressure deals with the collision of the molecules of the gas with the wall of the container. That's what we term as gas pressure, and then it is measured with a manometer. We said it's an instrument for measuring gas pressure. It works on the principle of the release of a gas into a tube, which in turn puts pressure on the liquid in the tube and pushes it up the tube, after which measurement is taken. This is an example of a manometer. You see the part that has gas. Let's look at the first diagram. When the knob is opened, gas is released into the tube. As it is released, it pushes the liquid, which is sometimes water or mercury, it pushes it down, hence causing a rise in the liquid on the other side of the tube. The other side of the tube is the calibrated part, and that's where the pressure of the gas is measured. The other end of the tube is opened. Atmospheric pressure acts on that part. If you look at the second diagram, as the gas pressure is pushing the molecule, the liquid down, and it is rising, the atmospheric pressure on the open end of the tube also has a downward push or effect on the liquid too. So to get the total pressure of the gas is actually equal to the atmospheric pressure, which is on the other end, plus the difference between the levels of the liquid, just as you have the small letter h in the first diagram. And then this is a physical example of the manometer. When the gas is released, it applies pressure on the liquid, pushing it downwards and then making it rise on the other side of the tube. That's how the manometer works. And then we'll go to the barometer. The manometer, we said, is used to measure gas pressure. The barometer is used to measure atmospheric pressure. It works on the principle of atmospheric air pressure on a liquid, causing it to rise up a capillary tube. How does this work? When we talk of atmospheric pressure, we're talking of the pressure caused by the molecules of air in the atmosphere on a liquid, mostly the surface of a liquid. This is a sample of the barometer. The blue arrows indicate the pressure from the atmosphere, or the pressure from the air molecules or gas molecules in the atmosphere. When the pressure acts on the mercury, in this case mercury is used. As you can see, the arrows at the bottom. When the pressure acts downward on the mercury goes into the tube and rises up the tube. Now, before this barometer is made, the top of the tube, there is no air inside. It is just vacuum. That means it is empty space. They made sure that there is no air inside the tube. So when atmospheric pressure acts downwards on the surface of the tube, as you can still see here, the mercury rises up the tube. So that rise is what is being calculated as the atmospheric pressure of the gas molecules present there. That's how the manometer works. The normal atmospheric pressure is 760 millimeters mercury. So normally, when we say 760 millimeters mercury, it means that the mercury rises up the tube to a height of 760 millimeters or 76 centimeters. That's what it means. So the calibrated tube is used to measure the atmospheric pressure. And now we begin the gas laws, one of which is Boyle's law. Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume, provided that the temperature remains constant. That means that as there is if the temperature of a gas is left constant, when there is an increase in pressure, there is a decrease in volume. Remember, we said the pressure of a gas has to do with how it collides with the container. So if you look at the diagram above, when the pressure was not increased, the molecules collided with the container, but they did so in very little proportions. But when the pressure was increased, the molecules collided more with the walls of the container. Hence, the pressure of the gas increased, but the volume was reduced. So Boyle's law is saying that at constant temperature, when there is an increase in pressure, there is a decrease in volume. So it is inversely proportional. Hence, you can see the formula here, where P is inversely proportional to V, P standing for pressure and V standing for volume. Hence the formula P1 V1 equal to P2 V2, where P1 is the initial pressure, V1 is the initial volume, and P2 is the final pressure, and V2 is the final volume. So basically, when we are talking about Boyle's law, we see that the pressure of a gas is increased when its volume is reduced, because the gas molecules collide with the walls of its container more as a result of reduced distances. That means that the distance, when you increase the pressure, the distance of travel for the molecules becomes short, so they collide more with the container, and increase in pressure comes with decrease in volume. Thank you for watching. Please attempt the questions on the content page, and I will see you in class. Thank you.